In a move that could redefine the future of energy, China has taken a monumental leap forward with the launch of its artificial sun. This groundbreaking achievement is not just a testament to China's technological prowess, but also a bold statement of its ambition to lead the world in clean energy innovation. The experimental advanced superconducting Tokamak, EAST, as it is officially known, is a fusion reactor designed to replicate the process that powers our sun. This development has sparked intense discussions across scientific communities, energy industries, and geopolitical circles. But what does this project mean for the future of energy, and why has China invested so heavily in achieving such a groundbreaking feat? The science behind the artificial sun. At its core, the EAST reactor is designed to replicate the process of nuclear fusion, the same reaction that powers the sun. Unlike traditional nuclear reactors, which rely on fission, the splitting of heavy atomic nuclei, fusion works by combining light atomic nuclei, such as hydrogen, to form helium. This process releases immense amounts of energy without the harmful radioactive byproducts that come from fission. Fusion is often referred to as the holy grail of energy because it has the potential to provide virtually limitless power with minimal environmental impact. The core of the EAST reactor operates at temperatures that exceed 150 million degrees Celsius, about 10 times hotter than the sun's core. Achieving and maintaining such temperatures is a colossal scientific and engineering challenge. Yet, the team behind this project has managed to sustain these temperatures for longer periods than ever before, setting multiple records in the process. This achievement places China at the forefront of fusion energy research, surpassing the efforts of other nations and organizations, including the United States and Europe. While countries like the US have been pursuing fusion through projects like ITER, the international collaboration in France, China's EAST reactor has proven that the race for fusion dominance is alive and competitive. But the artificial sun isn't just a scientific marvel, it's also a geopolitical statement. By launching this ambitious project, China is showcasing its technological power and signaling its readiness to lead the world in clean energy innovation. The geopolitical implications. Fusion energy has the potential to disrupt global energy markets and reduce dependence on fossil fuels. For a country like China, which has historically relied on coal and other non-renewable resources, fusion represents a pathway to energy security and environmental sustainability. China's leadership in fusion technology also raises questions about energy independence. By mastering fusion, China could potentially gain control over a technology that the rest of the world will desperately need as we move away from carbon-based energy sources. This could shift the balance of power in global energy politics, making China a major player in determining the future of energy supply. The artificial sun project is not just a technological achievement, but also a testament to China's commitment to scientific advancement. The country has poured billions of dollars into its fusion research, funding not only EAST but also other fusion-related initiatives. This level of investment demonstrates a long-term vision with the potential to pay off in unprecedented ways. If fusion energy becomes a reality, it could revolutionize how we power our cities, industries, and technologies. Beyond energy, a symbol of ambition. Beyond its energy implications, the artificial sun serves as a symbol of China's ambition in space exploration and scientific research. It's no coincidence that China has been making headlines with its lunar missions, Mars rover explorations, and satellite launches. The artificial sun aligns with these broader efforts, showcasing a nation determined to lead in both earthly and cosmic endeavors. Yet, despite its potential, the artificial sun is not without its challenges. Fusion technology is incredibly complex, and while EAST has made significant progress, practical fusion power plants are still likely decades away. Maintaining the extreme temperatures and pressures required for fusion is an enormous hurdle, as is finding materials that can withstand such conditions for long periods. There's also the question of cost. Even if fusion becomes technically feasible, making it economically viable will be another challenge entirely. These challenges highlight the importance of global collaboration in fusion research. While China's achievements with East are impressive, the pursuit of fusion energy is a global endeavor that requires the combined expertise and resources of multiple nations. Projects like ITER, which involve scientists from around the world, demonstrate the value of international cooperation in tackling complex scientific problems. However, China's rapid progress in this field raises concerns about whether the benefits of fusion technology will be shared equitably. If China succeeds in developing practical fusion power, will it make this technology available to the rest of the world, or will it use it as a bargaining chip in international relations? These are questions that the global community will need to grapple with as we move closer to a fusion-powered future. The broader implications. The artificial sun also has broader implications for how we think about energy and technology. It represents a shift from traditional energy sources to more sustainable and innovative solutions. As climate change continues to pose an existential threat, the need for clean, abundant energy has never been more urgent. Fusion offers a way to meet this need, but it also requires us to rethink our approach to energy production and consumption. In addition to its environmental benefits, fusion could also drive technological innovation in other areas. The extreme conditions required for fusion have already led to advancements in materials, science, superconductors, and plasma physics. These innovations could have applications beyond energy, influencing fields like medicine, transportation, and even space exploration. The launch of China's artificial sun is also a reminder of the importance of scientific curiosity and ambition. Achieving fusion energy requires pushing the boundaries of what's possible,
whether the benefits
and
of
it's a
fusion
testament to the
technology
power of human ingenuity. It's a reminder that the challenges we face as a species, from climate change to energy scarcity, can be overcome through innovation and collaboration. Yet, as we marvel at the potential of fusion energy, it's also important to consider its ethical and societal implications. Who will have access to this technology, and how will it be used? Will it exacerbate existing inequalities, or will it be a tool for global progress? These are questions that we must address as we move closer to a fusion-powered future. The future of fusion energy, China's artificial sun, has sparked a global conversation about the future of energy and technology. It's a symbol of what's possible when nations invest in scientific research and innovation. But it's also a reminder of the challenges and responsibilities that come with such advancements. Fusion energy has the potential to transform our world, but it will require us to work together to ensure that its benefits are shared equitably and responsibly. The artificial sun is a testament to human ambition and creativity. It's a reminder that the solutions to our greatest challenges are within our reach if we dare to dream big and work together. China's achievement is just the beginning of a journey that could change the course of history, and it's a journey that we must all take together. As we look to the future, one thing is clear: the race for fusion energy is on, and the stakes have never been higher. Whether it's China, the United States, or an international collaboration that ultimately unlocks the secrets of fusion, the impact will be felt across the globe. The artificial sun is more than just a scientific achievement. It's a beacon of hope for a brighter, more sustainable future. Fusion energy represents the culmination of decades of research and innovation. It's a reminder of what's possible when we invest in science and technology, and it's a testament to the power of human ingenuity. The artificial sun is a symbol of hope and progress, a reminder that we have the tools to build a better future if we work together. China's artificial sun is a milestone in the history of energy and technology. It's a testament to what's possible when nations invest in science and innovation, and it's a reminder of the challenges and opportunities that lie ahead. Fusion energy has the potential to transform our world, but it will require us to work together to ensure that its benefits are shared equitably and responsibly. The journey to fusion energy is a journey of discovery and innovation. It's a reminder that the solutions to our greatest challenges are within our reach if we dare to dream big and work together. The artificial sun is a symbol of hope and progress, a reminder that we have the power to build a better future. China's artificial sun has sparked a global conversation about the future of energy and technology. It's a symbol of what's possible when nations invest in scientific research and innovation. But it's also a reminder of the challenges and responsibilities that come with such advancements. Fusion energy has the potential to transform our world, but it will require us to work together to ensure that its benefits are shared equitably and responsibly. Fusion energy represents the culmination of decades of research and innovation. It's a reminder of what's possible when we invest in science and technology, and it's a testament to the power of human ingenuity. The artificial sun is a symbol of hope and progress, a reminder that we have the tools to build a better future if we work together. China's artificial sun project has already cemented itself as one of the most ambitious and groundbreaking technological endeavors in modern history. The experimental advanced superconducting Tokamak, East, has set new benchmarks in fusion research, inspiring both awe and intense debate worldwide. But as the research progresses, it's becoming increasingly clear that this isn't just about science. It's about reshaping the global balance of power, tackling existential environmental challenges, and reimagining the future of humanity. At the heart of this development lies a pressing question. Why is fusion energy so important? To answer this, we must first understand the monumental impact energy has on the trajectory of human civilization. Energy is the lifeblood of society. It powers our cities, drives industrial progress, fuels innovation, and sustains our daily lives. Yet, as populations grow and economies expand, the demand for energy continues to
the benefits of fusion
placing
technology
immense
will be
pressure on
shared
the planet,
equitably.
its resources, and ecosystems. Our current reliance on fossil fuels has led to devastating consequences: climate change, environmental degradation, and geopolitical tensions over oil and gas supplies. Fusion energy represents a way out of this crisis. Unlike traditional energy sources, fusion is clean, sustainable, and virtually limitless. It doesn't produce greenhouse gases, and its byproducts are far less hazardous than those of nuclear fission. The fuel for fusion, hydrogen isotopes like deuterium and tritium, can be extracted from abundant sources like seawater and lithium, ensuring that fusion reactors will never run out of fuel. Fusion also eliminates the risk of catastrophic meltdowns, as the reaction ceases immediately if containment fails. In other words, fusion has the potential to revolutionize how humanity generates energy, ushering in a new era of prosperity and sustainability. China's artificial sun is a critical step toward realizing this vision. By achieving record-breaking plasma temperatures and sustaining fusion reactions for longer durations, East is proving that the dream of harnessing fusion power is not as far-fetched as it once seemed. These achievements have profound implications, not just for energy production, but also for how nations perceive and interact with one another. Geopolitically, the artificial sun project is a clear demonstration of China's ambition to lead the world in science and technology. Historically, the United States and Europe have dominated major scientific breakthroughs, from space exploration to the development of the Internet. But in recent years, China has emerged as a formidable competitor, investing heavily in research and development across a wide range of fields. The artificial sun is just one example of how China is positioning itself as a global leader in innovation, challenging the traditional dominance of Western powers. This shift is causing unease in many parts of the world. Some view China's rapid advancements as a threat, fearing that it could use its technological prowess to gain leverage in international affairs. Others worry that China's achievements could spark a new kind of arms race, this time in the realm of energy technology. If fusion energy becomes the cornerstone of future economies, the nation that controls it will wield enormous influence over global markets and political dynamics. Yet, there's also hope that China's success could inspire greater collaboration among nations. Fusion energy is not a zero-sum game. Its benefits are universal, and its challenges are too complex for any one country to solve alone. By sharing knowledge, resources, and expertise, the global community could accelerate the development of fusion technology and ensure that its benefits are distributed equitably. Initiatives like ITER, the International Fusion Project in France, are a testament to the power of collaboration in tackling grand scientific challenges. However, The path to fusion energy is fraught with obstacles. Despite the progress made by East, practical fusion power remains elusive. The conditions required for fusion are extraordinarily demanding, and maintaining them for extended periods is a monumental engineering challenge. Building reactors that can operate safely, efficiently, and economically will require decades of further research and innovation. Moreover, the cost of developing and deploying fusion technology is astronomical, raising questions about who will bear the financial burden and who will reap the rewards. These challenges are compounded by the fact that fusion is not the only solution to the world's energy crisis. Renewable energy sources like solar, wind, and hydropower are already making significant strides in reducing carbon emissions and providing clean energy. While fusion has the potential to complement these sources, there's a risk that the immense focus on fusion could divert attention and resources away from other viable solutions. Balancing the pursuit of fusion with the expansion of renewable energy infrastructure will be crucial in the coming decades. Beyond the technical and geopolitical aspects, the artificial sun also carries profound philosophical and cultural implications. For millennia, humanity has looked to the sun as a symbol of life, power, and divinity. The idea of creating an artificial sun, of replicating the process that sustains all life on Earth, is both awe-inspiring and deeply unsettling. It challenges our perceptions of what it means to be human and raises ethical questions about the boundaries of scientific ambition. Should we strive to emulate the forces of nature, or are there limits to what we should attempt? These questions are particularly relevant in the context of China's political and social landscape. The country's rapid technological advancements have often been accompanied by concerns about transparency, ethics, and human rights. Critics argue that the same authoritarian governance model that enables China to mobilize resources for projects like the artificial sun could also lead to abuses of power and unequal access to the benefits of fusion technology. Ensuring that fusion energy is developed and deployed responsibly will require robust ethical frameworks and global oversight. Despite these challenges, the potential benefits of fusion energy are too great to ignore. Imagine a world where energy is abundant, clean, and affordable for everyone. A world where the air is free of pollution, where economies thrive without depleting natural resources, and where the fear of energy-related conflicts is a thing of the past. This is the vision that drives fusion research, and it's a vision worth pursuing. China's artificial sun is a powerful reminder of what humanity can achieve when it dares to dream big. It's a testament to the ingenuity, perseverance, and ambition of scientists and engineers who refuse to accept the status quo. It's a beacon of hope in a world that desperately needs solutions to its most pressing challenges. As we reflect on the significance of this achievement, it's important to remember that the journey to fusion energy is not just about technology. It's about humanity's ability to work together for a common goal. The challenges we face are immense, but so is our capacity for innovation and collaboration. The artificial sun is a symbol of what's possible when we rise to meet those challenges, and it's a reminder that the future is ours to shape. In the coming years, the progress made by East and other fusion projects will be closely watched by scientists, policymakers, and citizens around the world. The decisions we make today will determine whether fusion becomes a reality or remains an elusive dream. By investing in research, fostering international collaboration, and addressing the ethical and societal implications of fusion, we can ensure that this technology fulfills its promise and benefits all of humanity. China's artificial sun has ignited a new era of scientific discovery and global competition. It's a bold statement of technological prowess, a harbinger of a brighter future, and a reminder of the power of human ingenuity. As we stand on the brink of a fusion-powered world, the choices we make will define the legacy of this remarkable achievement. Let's rise to the challenge and seize the opportunity to create a sustainable, prosperous, and equitable future for generations to come. The Artificial Sun Project, spearheaded by China's East Reactor, is not only a scientific marvel, but a transformative initiative reshaping the future of energy. Its progress is forcing scientists, policymakers, and the public to confront the reality that fusion energy is no longer a distant dream. It's becoming an achievable goal. However, the story of fusion energy isn't just about science. It's about humanity's ambition, our desire to master nature's greatest secrets, and the broader implications for life on Earth. To truly understand the significance of the artificial sun, we must explore its potential impact across various dimensions: scientific, environmental, geopolitical, and societal. One of the most intriguing aspects of the artificial sun is the profound scientific revolution it represents. Fusion energy is based on the process that powers stars, including our sun. At its core, fusion involves combining light atomic nuclei, such as hydrogen isotopes, under extreme heat and pressure to form heavier nuclei. This process releases an enormous amount of energy. Unlike nuclear fission, which splits heavy atoms and produces long-lived radioactive waste, fusion is a clean and relatively safe energy source. The challenge, of course, is replicating the conditions of a star on Earth. Stars achieve fusion through their immense gravitational forces, which confine hydrogen nuclei at extremely high pressures and temperatures. On Earth, scientists must create these conditions artificially. This is where devices like Tokamaks, including China's EAST reactor, come into play. Tokamaks use powerful magnetic fields to confine superheated plasma, essentially a state of matter where atomic nuclei and electrons are separated, in a donut-shaped chamber. The plasma must reach temperatures of millions of degrees, far hotter than the core of the sun, to overcome the repulsive forces between positively charged nuclei. China's East reactor has already achieved record-breaking plasma temperatures, exceeding
concerns
100
about whether the
million
benefits
degrees
of fusion
Celsius.
technology will
This
be
is a crucial milestone, as it demonstrates that we can create and sustain the extreme conditions necessary for fusion. However, achieving high temperatures is only part of the equation. Scientists must also find ways to maintain these conditions for extended periods and ensure that the energy produced by fusion reactions exceeds the energy required to sustain them. This balance, known as net energy gain, is the ultimate goal of fusion research. As scientists push the boundaries of fusion technology, they are also unlocking new insights into the fundamental forces of nature. Fusion research is deeply intertwined with plasma physics, quantum mechanics, and materials science. Understanding how plasma behaves under extreme conditions, for example, could lead to breakthroughs in other fields, from astrophysics to nanotechnology. Fusion experiments also require the development of advanced materials that can withstand the intense heat and radiation generated by the plasma. These materials could have applications far beyond energy production, from space exploration to medical technologies. But the scientific revolution sparked by the artificial sun is only one piece of the puzzle. The environmental implications of fusion energy are equally profound. Today, the world is grappling with a climate crisis fueled by the burning of fossil fuels. Carbon dioxide emissions from coal, oil, and natural gas are driving global warming, causing extreme weather events, rising sea levels, and widespread ecological disruption. Transitioning to clean energy sources is essential to mitigate these impacts and ensure a sustainable future. Fusion energy has the potential to be a game changer in this regard. Unlike fossil fuels, fusion does not produce carbon emissions. Its primary byproducts are helium, a harmless, non-toxic gas, and a small amount of low-level radioactive waste. Fusion reactors also do not require large-scale mining or drilling operations, reducing their environmental footprint. By providing a virtually limitless source of clean energy, fusion could help us phase out fossil fuels.